Welcome back to the deep dive. Okay, imagine trying to perfectly trim thousands of tiny little imperfections off precision parts, day after day.
Yeah, sounds tedious.
Right. Tedious, easy to make mistakes, and maybe even a bit risky for people doing it by hand.
Mm-hmm.
But that's exactly the problem degating and deflashing robots were built to solve. And the demand for them is just skyrocketing globally.
It really is.
So today we're diving deep into this, really fascinating, fast-growing slice of the whole automation industry. Our plan is to unpack the key insights from our main source here, robotic automation market, global growth trends and forecasts, which uses some amazing data from cognitive market research.
Good stuff.
We're going to pull out the really important bits, the surprising facts, just to get you up to speed quickly on why this seemingly niche area matters so much.
And you're spot on. Delegating and deflashing might sound super specific, almost technical jargon.
Yeah, a bit.
But understanding its, explosive growth, it actually tells us a lot about bigger, really critical trends in manufacturing, in technology adoption worldwide. It's a great way to look at where industrial automation is heading.
Okay, great. Let's unpack this then, starting with the big picture, because the global growth is, it's pretty remarkable.
It is.
Back in 2021, the whole market for these specific robots, it was valued at just over, $2 billion? $2,029.21 million, to be exact.
A solid number to start with.
A solid number, but here's where it gets really interesting. That figure, it's projected to jump to over $3,108.1 million by 2025.
Okay, quite a leap in just a few years.
And then, get this, it's expected to more than double again, to nearly $7.3 billion by 2033.
Wow. 7,291.77 million.
Exactly. That kind of growth, it's a compound annual growth rate of 11.248%. That signals a really strong, sustained momentum. It feels like a fundamental shift.
Yeah, what's fascinating here is putting those numbers in context. When we say degating and deflashing, what are we actually talking about?
Right. What do they do?
So these are robots designed for precision work. They meticulously remove the extra bits of material left over when parts are molded. Think about a plastic component or maybe a metal one coming out of a mold.
There's always that little extra bit.
Exactly. Those little bits, they're called gates or flash. They need trimming off perfectly for a clean finish. These robots automate that. It's precise, it's repetitive, and frankly, often quite tricky to do manually.
I can imagine.
So the rapid growth we're seeing, it links directly to this broader push in manufacturing for, higher precision, better efficiency, and obviously cost savings, big cost savings.
So it's more than just general efficiency then. Are there specific pain points right now making these robots so crucial, like maybe labor shortages for those specific finishing jobs, or maybe product designs getting so intricate that humans just can't keep up consistently?
Oh, absolutely. Both are factors. A huge driver is the demand for, frankly, flawless product quality. Consumers, other industries, they expect near perfection. Even tiny flaws aren't acceptable anymore. Right.
Manual work can lead to inconsistencies, fatigue, human error. It happens. Robots offer that incredible repeatability, accuracy, time after time.
Okay.
And you hit on another key point, design complexity. Modern parts often have really intricate shapes, tiny details. Finishing those by hand without causing damage, it's incredibly difficult, sometimes impossible.
Yeah, I could see that.
And then, yes, labor costs and safety. These tasks are often monotonous, repetitive. Workers might be exposed to sharp edges, maybe hazardous materials, depending on the part. Automation solves all that pretty neatly. So yeah, that's why we see this really strong adoption curve.
That adds a lot of color, thanks. So, okay, we've got this global explosion in demand. But what's really interesting is how it breaks down geographically. Instead of, marching through every single country, maybe you could highlight a couple of regions. Perhaps contrast Africa's super fast growth with a more mature market, say North America. What does that comparison tell us?
Sure, that's a great way to look at it. Let's start with Asia Pacific. It's a huge driver in terms of sheer volume.
Okay. It's projected to go from around $800 million back in 2021 to over $3 billion by 2033. That's 809.653 million to 3,019.52 million, growing at about 11.7% a year. Strong, steady growth.
And within the Asia Pacific.
China and Japan are the big players there. China's expected to cross $900 million by 2033, Japan over $698 million. But India is also really remarkable. Its growth rate is over 12.6%, looking to hit nearly $600 million by 2033 from about $144 million in 2021.
Wow, more than quadrupling.
Yeah, and you also see places like Singapore with the highest growth rate in the region, over 13%, and Southeast Asia generally showing very high growth too. Just reflects the sheer scale of manufacturing there and the constant investment in upgrading.
Okay, so that's the established giant ramping up. Now, what about Africa? You mentioned that contrast.
Right. Africa is, well, it's the fastest growing region globally. The CAGR is predicted at a, frankly, staggering 15.222%.
15%.
Yeah. Now, the starting point is smaller, naturally. It was about $34.5 million in 2021, but it's projected to surge past $175 million by 2033.
Still, that rate of increase is huge.
It is. Nigeria and South Africa are leading that charge, both with growth rates above 14.8%. And the rest of Africa's segment is actually growing even faster, around 15.6% annually.
So what does that tell us?
It suggests that regions maybe with less established older manufacturing bases are actually jumping straight into advanced automation. They're potentially leapfrogging older methods to build modern, efficient industries almost from scratch. It's a really powerful signal, I think.
That is a powerful contrast. Okay, so established giants upgrading, emerging markets leapfrogging. What about the other established industrial areas like North America and Europe? Are they keeping pace?
Oh, definitely. They're not being left behind. North America is a very significant market. It's set to grow from nearly $600 million in 2021, $586.441 million to over $2 billion by 2033.
So very strong growth then.
Absolutely. A HGR of about 10.6%. The U.S. takes the biggest chunk of that, obviously projected to hit over $1.5 billion itself. But Canada's growth rate is strong too, over 11.5%. And Mexico is also growing robustly, expected to reach about $175 million.
And Europe. Similar story.
Pretty similar, yeah. Europe started around $383 million in 2021 and is forecast to cross $1.3 billion by 2033. That's a CAGR of about 10.7%.
Okay.
The UK, Germany, France, they're the key players. France actually has a particularly high growth rate, over 12%, but you also see strong performance in Italy, Russia, Spain, and even double-digit growth in places like Switzerland, Luxembourg, and the rest of Europe combined.
So the push is definitely there across the board in developed economies too.
Exactly. Even in mature industrial economies that drive for better precision, more efficiency, improved safety, it keeps fueling substantial investment in this kind of specialized automation.
Gotcha. And just quickly, South America and the Middle East, what's the general picture there?
Right.
Similar adoption patterns.
Yeah, broadly similar trends, just maybe on a different scale. South America is projected to more than quadruple its market value by 2033, starting from about $142 million in 2021. Brazil leads, but Argentina and Colombia are showing really impressive growth rates, both above 13%. And the Middle East, while it's a smaller market overall, around $73 million in 2021, it's also growing steadily. It's projected to nearly triple, reaching about $210 million by 2033. The UAE actually has the highest growth rate in that region, nearly 10%.
So it really is a global phenomenon there.
Yeah, it seems to be, yes.
Yeah.
A widespread embrace of this very specific but clearly very critical type of automation.
Okay, so let's try and sum this up. What we've really explored today is this deep dive into what seems like a niche area handling degating and deflashing robots.
Yeah.
But it's actually a critical part of industrial robotics.
Yeah.
And it's seeing just explosive, sustained growth all around the world.
That's right.
And it's not just about general automation trends, right? It seems driven by these really fundamental shifts in what manufacturing needs. Extreme efficiency, pinpoint precision, and keeping workers safe.
Precisely. And, this raises a really important question for you, the listener, to think about. Given this incredible pace of adoption we're seeing and the sheer size this market is projected to reach, what other transformations could this trigger in global manufacturing? How might this widespread use of specialized robots impact, say, supply chains, or the actual quality we expect from products, or even, the kind of skills needed in the workforce over the next decade?
Those are some powerful questions. Definitely something for you to mull over as we wrap up this deep dive. Thank you so much for joining us today. We really hope you'll keep exploring this fascinating world of automation and just how much it's changing things around us. Welcome back to the deep dive. Today, we're plunging into, well, a really fascinating corner of modern manufacturing. It's all about handling, degating, and deflashing robots. Now, those terms might sound a bit technical, maybe a bit niche.
Yeah, they can do.
But think of them as the sort of unsung heroes of precision cleanup.
That's a good way to put it.
These are the machines that remove that extra material,
Mm.
the little plastic bits left on something after it's molded.
Right, or the metal runners from a casting, flashing gates.
Exactly. They make sure every single part is, well, perfect. And our dive into the latest insights, it really gives us a clear look at a market that's, well, it's not just growing, it feels like it's really taking off.
It absolutely is.
So our mission today, like always, is to pull out the most important insights, maybe some surprising facts too. We want you to walk away feeling well-informed, quickly but thoroughly, on how this tech is really transforming manufacturing. Precision, efficiency, all that good stuff.
And what's really compelling, I think, is why now? Why is this market hitting such a sort of significant point right now?
Good question.
It's not just, steady growth. We're seeing this huge global push from manufacturers. They want more automation, sure, but specifically for these unprecedented levels of precision, especially in areas like foundry work, injection molding, die casting, really critical industries.
Ah, okay. So it's not just about speed then.
No, not just speed. It's about hitting a level of consistency, of quality, that frankly manual work just can't reliably match anymore. It's becoming fundamental for staying competitive, really.
Okay, let's unpack that a bit. When we look at what's driving this momentum, a few things really jump out from the research, don't they?
They do.
You mentioned that surge in automation die casting, injection molding especially.
Mm-hmm.
What's interesting is how the demand for like ultra-high precision and efficiency, it's not just a nice to have anymore, is it?
Not at all. It's making robotic handling and trimming an absolute strategic necessity.
Right, so we're moving beyond just getting the job done.
Exactly. It's about doing it with micron-level exactitude every single time. And for some industries, that precision actually unlocks completely new design possibilities they couldn't achieve before.
Wow.
And if you connect that to the bigger picture, well, it's also being sped up by some very real global economic stuff.
Like what? Labor issues.
Yeah, exactly. We're seeing increasing labor shortages everywhere, rising wages too, particularly for these repetitive, sometimes pretty hazardous tasks like degating and deflashing.
Tasks that are kind of perfect for robots then.
Perfectly suited. These systems can run 24/7, no breaks, no risk of injury, tireless. But the real game changer, I think, and something our sources really highlight, is the huge improvement in product consistency and quality.
How so?
Well, by ensuring totally uniform force and motion control, they just eliminate human variability. Simple as that.
Ah, okay. The human factor.
Right, and that level of consistency is absolutely essential in sectors like automotive, aerospace, even medical devices. Places where a tiny imperfection isn't just a cosmetic issue. It could be, catastrophic, or just render the whole part useless.
So it's about unmatched consistency, reliability, leading to quality control that was, almost unimaginable before.
Pretty much.
That sounds incredible. But like any big tech shift, it surely comes with challenges, right? It can all be smooth sailing.
Oh, definitely not. Our research clearly shows that despite the advantages, there are some headwinds.
Like cost.
Cost is a big one. That high capital investment up front, that's a significant barrier, especially for smaller companies, the SMEs.
Yeah, getting those sophisticated systems installed is a major spend.
It really raises questions about accessibility,
Yeah.
for manufacturers of different sizes. And beyond just buying the robot, customizing it for different parts,
Yeah.
that adds another layer. Setup time, more expense.
Because parts aren't all the same shape and size.
Exactly. That flexibility isn't free. Each new part geometry often needs complex programming, maybe custom tools.
Right.
Plus, trying to plug these cutting-edge robots into, say, an older production line, that brings its own set of headaches.
Yeah, it's a integration challenge.
Big time. Technical hurdles, financial ones. It can really slow down modernization efforts. It's definitely not always just plug and play.
Yeah, you need serious engineering work to get new and old systems talking.
You do.
That makes total sense, especially with how long some production lines have been around. But what's fascinating is how overcoming those hurdles is actually sparking some really cool innovation in this space.
It is, yeah. Necessity and invention, right.
One big trend we're seeing that the materials really dig into is the rise of collaborative robots, cobots.
Ah, yes, cobots. Very interesting area.
Yeah. These aren't your typical industrial robots locked away in a cage. They're designed to work safely right alongside people, which enables much more flexible automation, even in places that are maybe semi-automated or tight on space.
It opens up possibilities.
Imagine that, a robot and a human sort of working together on the line.
And what's truly revolutionary, I think, is the leap we're seeing with AI. AI-driven systems, vision-enhanced systems.
Okay, tell me more about that. Giving the robot eyes and a brain.
Essentially, yeah. High-speed cameras capture the part in real time. Then AI algorithms instantly analyze that image. They identify exactly where the excess material, the gate, or the flash is, even if every part is slightly different.
Whoa, so it adapts on the fly.
Precisely. It enables adaptive trimming without needing rigid, pre-programmed instructions for every single little variation. It literally sees and adjusts.
That must boost throughput and flexibility massively.
Dramatically. But it's not just about speed and precision, though those are huge. There's a really significant sustainability angle, too.
How so? Waste reduction.
Exactly. Think about manual deflashing. Often, to be safe, workers might trim off a bit too much material, just in case.
Right, better safe than sorry.
But that leads to unnecessary material waste. These robots, with their pinpoint precision, can cut that waste down, sometimes by like 15–20% per part.
Per part, that adds up quickly.
Across high-volume production, it adds up to tons of material savings, which is, a massive win for the environment and for the company's bottom line.
Okay, so let's try and wrap this up for you, the listener. What does it all mean? We've seen how this market's being, well, radically reshaped. That surge in automation, especially in die casting, injection molding, it's huge. And it's not just about doing the job anymore. It's about that absolute need for high precision, high efficiency in modern manufacturing.
It's table stakes now, almost.
Right. And we can't forget how things like global labor shortages, rising wages, they're really pushing companies towards these tireless, precise robots for those tedious or hazardous jobs.
Accelerating the trend, definitely.
The core benefit seems crystal clear. Much better product consistency, higher quality, thanks to that uniform force and motion control, which is just vital for sectors like automotive, aerospace, medical, where perfection isn't just nice, it's required.
Absolutely critical.
Now, there are challenges, for sure. That big upfront investment is real. Customization costs add up. Integrating with older lines can be tricky.
Hurdles to overcome.
But the innovations are exciting. We're seeing cobots making automation more flexible, more human-friendly. And then there's the AI and vision systems, allowing for that real-time adaptive trimming. That feels like the future.
It really does.
And hey, they even help hit sustainability goals by cutting down material waste significantly. This deep dive, it really shows just how multifaceted this technology's impact is on manufacturing's future.
Yeah, and if you connect all those dots, the precision, the adaptability from AI and vision, those sustainability drivers, it means these de-Degating and deflashing robots, they aren't just another tool. They're not just machines in the factory anymore.
What are they then?
They're becoming sort of central figures in how manufacturing evolves. They're enabling production processes, even product designs that just weren't possible before.
Yeah.
So here's something to maybe think about. As these capabilities get even smarter, even more widespread, what new frontiers might they unlock? In industrial design, maybe, in operational efficiency, how might they push the very definition of what's possible in mass production?
That's a really interesting question to leave things on, pushing the boundaries of what's possible. Well, that's all the time we have for this deep dive. Thanks so much for tuning in.